Okay, so what I have here are the 6 steps for hypothesis testing for proportions. If you were doing something like hypothesis testing for the mean, the steps can be a little bit different, namely steps 3 and 4. But for now, since we're doing hypothesis testing for proportion, these are our 6 steps. Step number one. Step number one says state the null and alternate hypothesis. So the null hypothesis is always when the proportion is equal to some value. So just note that we always use the equal sign for the null hypothesis. The alternate hypothesis involves P, the population proportion, and some numerical value. But depending on the wording of the problem, there's 3 cases, one of the three. We can have not equal to, we can have less than, or we can have greater than. We will have the not equal to whenever the problem does not make any reference to the other two, namely if it doesn't make any reference for less than or greater than. If it does say less than, then we use the less than symbol. If it states greater than, then we use the greater than symbol. But if it doesn't make any reference of less than or greater than, or any synonyms to it, to those words, then we have to use the not equal to. My second step, this is just to help out students. Usually your professor won't ask you this on an exam, but maybe I would. It says make a sketch. You label your significance level and determine if it's a two-tail, left tail, or right tail test. So when I say label the significance level, I'm referring to the value that we call alpha. So they'll tell you what's your significance level or your alpha in the problem. That corresponds to the area in a left tail and a right tail or a two tail. And by the way, depending on the sign of your alternate hypothesis, you would know if it's a left, right, or a two tail. Like for example, I'm just gonna re-highlight this. If I have a not equal to would be a two tail. If it was a left tail, then you have the less than symbol. And if you have a greater than, then it's a right tail. Okay. What's up?
I just came to see the review and check.
Oh, I'm just doing a video.
Okay.
Yep. You guys grab a seat. Yes, you can move my bag. All right. That was one of my two. Okay, so steps 3 and 4 is the calculator step. That's where you find the test statistic and the p-value. So I think on the final exam, it's gonna say one part will say find the test statistic. I label that as my z test value, by the way, and you find the p-value. So if you want to do this in the calculator, we use the one proportion z test command. So the way that we get that is we click stat, followed by clicking on tests, or you uh, gotta scroll over the test and then hit enter. And then you select the one proportion z in. So it's the one I'm highlighting on the screen. Okay. And then you enter the stuff. Okay. So I'll leave the screen the way it is for right now, or I'll clear it. And then lastly, steps 5 and 6 is you make your decision and then interpret the results. So if the p-value is less than or equal to your significance level, then you reject. If p-value is greater than alpha or your significance level, fail to reject, and then just go to interpret your results. Just put it in plain English. Do you say that you support? Do you have enough evidence? Do you not support? Whatever the case may be. Okay. So let's look at problem 12 to see how these 6 steps are being manipulated or completed. So problem 12 states a television show conducted an experiment to study what happens when a butter toast is dropped on the floor. When 53 butter slices of toast were dropped, 30 of them landed with the butter side up and 23 landed with the butter side down. Use a significance level of 0.05 to test the claim that the toast will land butter side down 50% of the time. So there's 6 steps, there's 6 parts to this problem, and we're gonna do all of them. the very first step states to identify, again, the null and alternate hypothesis. So your null hypothesis, you always call it HO. The alternate, you always call it HA. Sometimes your professor might use H1 because the null was HO, but I use HA. A stands for alternate. It makes a little bit more sense to me. Now, what we have is the population proportion. I'm going to have it for both of them. For part A, for the null, we always say P is equal to some value. So in this case, the claim here is that we want to test the claim that the toast will land butter side down 50% of the time. So P is equal to 0.50, right? 50% as a decimal is 0.50. In this problem, it does not make, if you ever want to reread this, reread what's in blue, it doesn't make any comments on less than or greater than. So because it makes no comments on less than or greater than, the alternate hypothesis must be the not equal to symbol. So P is not equal to 0.50. So our original claim, the claim of this argument, is going to be your null hypothesis. So I'm going to label that as my claim. Because when I do my interpretation of my results, I'm going to write it based off of the null or based off of my claim, which in this case is the null hypothesis. All right, so part A is done. That's all you have to do for part A. Now we proceed to part B. So in part B, you want to make a sketch. So let me just do a little bit of erasing. Erase everything. So part B, when you make your sketch, you can informally make a sketch of a normal distribution and you can label it. There's things that you can label. And the things that I'm labeling here, I mean, this is not the best normal distribution, but it's going to work for us nonetheless. There's some important label that will come to play in later on, especially when I get to parts E and F. So what do we have here? Well, since the alternate hypothesis has the not equal to symbol, then we're going to have a two-tail test. Now, since I have a two-tail test, that means that the area, the value of alpha, which was 0.05, will be the area in both the left and right tail combined, right? So this area in the left tail and this area in the right tail is going to be 0.05. All right. That's all we needed for the sketch part, was identifying what type of test do we have and figuring out where is your level of significance. All right. Now we're up to parts C and D. So for parts C and D, finding the test statistic and the p-value, we can do this in the graphing calculator. So for part C, we have figure out the test statistic. Again, I label this as Z with like an underscored word of saying test, so like Z test. And then for part D, we have the p-value that we have to find. So the one proportion Z test gives us these values. The first thing that you have to enter is PO. So on my screen to the right, just showing you how I got this. I did I did stat, tests, one proportion Z test. So what I have to enter in the box is four things. The first thing I enter is what the population proportion is equal to, which is 0.5. I enter the value of X. So what X represents is basically the toast that were butter side down. So there were a total of 23, there were 23 toasts that were butter side down. We have N is the number of butter slices, which is 53. And I make sure that the prop highlights exactly what's there for the alternate hypothesis. All right, so if it was a left tail, I would use the second symbol, the one that was in the middle. If it was a right tail, I select the one that was on the right, but because it's a two tail, I have to use the not equal. And then you hit calculate. Nope, sorry, I think I hit draw. Oh, there we go. And we have everything there for this problem. So your test statistic your z-test value, if you round it to 2 decimals, is negative 0.96. Your p-value, you can round this off to 4 decimals. You get 0.3362. So that's what part C and D is now done. The graphing calculator does the two heavy calculations for us. Now he's got to focus on making the decision and interpreting our results. So here we have that the p-value, again, just rewriting it for us, was approximately 0.3362. We have the level of significance was 0.05. So when you compare these two, the p-value is clearly bigger than the level of significance. So this means that you were, in this case, fail to reject the null. You failed to reject the null. All right. If you fail to reject the null, you move on to part F, which is where you make a decision. So the way that you, sorry, not make a decision, you interpret your results. The way that we can say our interpretation is that since we failed to reject the null, then there is not enough evidence or sufficient evidence to support the claim, whatever the claim was. The claim was that the toast will land butter side down 50% of the time. And that's hypothesis testing for problem, the first problem. I'll do the second and third problem in the next video.